Hey, yay, I'm a minute early. I haven't had such a great day today. I forgot to tell my husband to pick up the neighbor's little boy from preschool, so he was stuck there and his grandma had to get him. So I look like a pretty big jerk with that one. And uh, and then I misscheduled a call. So the fact that I was here on time today makes me feel pretty darn good. We'll see who can attend and who watches later. So I'm going to quickly go through the unit project, and then I've kind of had a couple of common questions on this unit, so I was going to address those while I was here and see if it helps anybody. So let's first jump to the unit project. You can see all my tabs today. I'm very busy. That's probably why I mess things up. But on the course page, let me go back one bit because I already clicked on it. On the course page, you'll see that this time it's after the unit assessment. But you can start working on the project even if you want to wait a little bit on the unit assessment. So as soon as you've turned in your concept map for Unit 3, you can click on this link for the unit project and you'll see your assignment. So when I think of polynomial functions, I've always thought of roller coasters. And so this is a set of different application problems that do work through how we can model roller coasters with polynomials. So you're going to turn in, there's 18 problems, and you need to make sure you really show your work. The real difference between A and B level on this, in my opinion, is that you're able to do this independently for A level, and you clearly communicate how you're solving the problem. So there's not just numbers written, but you're showing your work, you're writing out explanations. And B is if you need me to kind of help you. I'm not going to do it all for you, but I'll help you where you get stuck. If you get stuck once or twice, you'll still have a chance for the A. It's kind of how much help, but I think after I go through it here, you'll see. So we have, it says Fred, Elena, Michael, and Diane enjoy roller coasters. Whenever a new one opens, they want to ride it. On Saturday, the four friends decide to ride a new roller coaster. While waiting in line, Fred notices that part of this roller coaster resembles the graph of a polynomial function they've been studying in their advanced math class. So the brochure of the coaster says that for the first 10 seconds of the ride, the height of the coaster can be determined by this polynomial function, where t is the time in seconds and 8 in the height. Classify this polynomial by degree and number of terms. Easy peasy, right? And you're going to graph it, and you're going to say whether it makes sense. So I'm not going to read through every question. Some of them, here it's asking you when the height is 60. Does that make sense? And it even kind of gives you a reference. It tells you how tall Mount Everest is. And so you're going to go through and see that there are 18 questions here. If you can't interpret one, don't be afraid to ask on that A-B thing. So if you have a question, you can ask it, and I'll try to give you very little help at first and then see how much help you need. So this is your project. I think it's pretty straightforward. In my Advanced Math 2 class, we kind of extend this, and we have a engineering problem to actually design a roller coaster. So if you're doing Advanced Math 2, you'll get to do that next. So that's the project. I'm going to just quickly go back over here into where I can see you if there's any questions. So if there's any questions, just let me know. Any questions can be typed in here. So pretty straightforward on the project. The other thing I want to go over is this idea of, I've had quite a few questions on what does multiplicity mean. So, and I've tried to kind of see that if I have a function like x minus 2, I have a solution here at 2, and it passes straight through it. And if I change that to squared, I still have only one solution here at 2, but the fundamental theorem of algebra says if I have a degree 2, I have to have 2 roots. So how we take this into account is we say, okay, x equals 2 with a multiplicity of 2. If we wanted to change this, just so I don't have too many 2's here, let's say I have x plus 4, right? X equals negative 4 is my solution, right, when y equals 0. If I square that, it's still the only solution, but we say x equals negative 4 with a multiplicity of 2. If I do cubed, oh, look at that. I still only have this one real 0. So what do I say? X equals negative 4 with a multiplicity of 3. And we can really quickly see that even numbers mean that the graph is bouncing. right? Even if I put a negative out in front and I turned it over, the graph is still coming here and going back. And does it matter what even number? No, right? 48 still only has that solution, right? It's an even number. We say -4 with a multiplicity of 8. If it's an odd number, it's going to pass through that point. And that also helps us know what the graph is going to do when I have the multiplicity. So if you know you have a function, let's say I know I want x to equal 3 with a multiplicity of 2. Sorry, I don't want negative. X equals 3 with a multiplicity of 2. Well, I know that that graph is going to bounce back up there. The other thing that's been coming up quite a bit is this idea of these complex conjugates. So let's say that I know x equals I, so I have this minus I here. And this is an imaginary number, it's not a slider, which is what this wants to do. So it doesn't want to have this be imaginary. But let's say I put x minus I, or x plus I is another imaginary. Desmos isn't going to let me do imaginary roots. Let's just do x squared plus 25. That's because I have to go up higher, don't I? So let's zoom out, right? I just made it go up 25. So let's go up so we can see it at 25. So I just shifted that graph up 25. And I don't see any real roots, right? There's no place that it touches this axis. Well, how if I know Desmos doesn't do imaginary numbers, but if I wanted to write this function out as its factors, I would have to write x minus 5i times x plus 5i, right? So whenever we have a function up here, and it has real coefficients, there's a real number here, there's a real constant here. Whenever I have a polynomial with real coefficients, and we haven't seen any that don't have real coefficients, then I know if one complex conjugate, or if one imaginary number is a root, its complex conjugate is another root. All right, let's look at this in terms of, we can also look at this when we have square roots. So let's say x minus the square root of 2, usually lets me do square root, there we go. Square root of 2 is a root, right? And if I said square that, well, that's going to be kind of funny, because if I multiply this out, I'm going to have x squared minus 2, minus 2 square root 2x plus, right, negative square root 2 times negative square root 2 is going to be plus 2, right? And it looks, this x actually needs to be outside of here. And then we get the exact same function, right? So, and we've never dealt with this. We haven't had any functions where there's a square root here. So this doesn't exist. We're not dealing with this. All of our coefficients have always been real numbers. So how do I deal with that? Well, if you're told that the square root of 2 is a root, then, and you're told that there's real number coefficients, rational coefficients, then you know that this also has to be a root, right? I have to have, and then look what happens here. We see that this is this negative square root of 2 and this is the positive square root of 2, but both of these exist. These are ideas of, this is the idea of,
Mommy, can we get that now, Cherry?
When I'm done. I'm making a video right now when I'm done. Okay, can you wait? Thank you. So whenever I have a square root as one root, I'm going to have its conjugate is the other root. So I hope that helps. Those are the bigger questions I've seen in this unit. If you're stuck on anything, as always, just write me and I'm more than happy to help. So thank you, and if I don't see any questions, I'll kind of sit and drink my coffee for a couple minutes. I'll just see if any questions come in, and if no questions come in, then I'll go ahead and you'll go on. See, everybody left. They're done. Anyways, thank you.